Excellent. Streaming and ready to go. CIS 75 now in module number 9 as we cross the halfway point into the second half of the course. This chapter is all about cloud and virtualization. Kind of funny for me because we started with using the cloud and virtualization right off the bat in the first week, and the subject itself doesn't show up until the 9th chapter, or 10th chapter, actually. Oh, well, no problem. Cloud service providers deliver computing services to their customers over the internet, as you know. Many of the key benefits of the cloud derive from it having various qualities, such as on demand, where you can provision or deprovision almost immediately, where you can oversubscribe, since not everyone uses all their resources at the same time, and multi-tenancy. Many users will share resources in the same infrastructure. You can have a variety of configurable computing resources. You can also merge different cloud providers together. So just because you are on AWS, for example, does not mean you can't use the Google Cloud or DigitalOcean or Microsoft's Azure. A lot of businesses actually are multi-cloud, where they'll use different providers. Should one go down, the other one can keep up. That's hard to do by yourself without having a lot of infrastructure around the world in many different regions and zones, and be active all the time. So a lot of businesses not only use the cloud in order to make their infrastructure accessible, but also use multiple clouds as backups, load management, all that kind of stuff. So some benefits, as I already said, it's on demand. The cloud is available when you need it. The cloud can scale. You can manually or automatically increase the capacity of your cloud operation. And you can do that either vertically, where you increase the capacity of existing servers, or horizontally by adding more servers to a pool of clustered servers. So once again, some people get confused about that. So vertical scalability means you're adding capacity to existing servers. It's the equivalent of having a virtual machine with 2 gigabytes of RAM and then upgrading to 4 gigabytes of RAM. You didn't add more servers, but you increased the one you had. That is a vertical scale. Horizontal just means adding more. So instead of having 1 server, you have 2. That's a horizontal scale. Both are completely achievable with the cloud. Clouds are all elastic. Their capacity can expand and contract as you need in order to optimize costs. So you launch your website for the first time and there's a whole lot of traffic. The cloud can be elastic enough to meet those needs. And then when traffic dies down, it will reduce what you have and life continues. All cloud providers have measured service, where everything that is done is measured by the provider and you pay for exactly what you use. There's agility and flexibility. speed to provision resources and use them for short periods of time. So again, as you need them, it will be provided. There are various cloud roles that you should be familiar with. The first is the service provider. These are firms that offer cloud computing services. They may build their own data center or work hand in hand with other providers to deliver their service. The consumer, that is you. Oops. You are the person who purchases cloud services from providers. There is the partner or a broker. They offer ancillary products or services that support or integrate with offerings from a provider, like training, consulting, software development, integration services. There is the auditor. Oops. An independent organization that provides third-party assessments of cloud services and operations. And lastly is the carrier. Intermediaries that provide connectivity from providers to consumers. There are different cloud service models. 4 that show up in the Security Plus exam are the infrastructure as a service, software as a service, platform as a service, and function as a service. So infrastructure, the one way down at the bottom in purple, allows customers to purchase and interact with basic building blocks of infrastructure like computing, storage, and networks. Customers do not worry about any underlying hardware and any physical facility. Software as a service, on the polar opposite, in green, provide customers with access to fully managed applications running in the cloud. The provider is responsible for everything from the operation of physical data centers to the performance management of the application itself. The customer is responsible for limited configuration of the application, the selection of what data they wish to use with the cloud solution, and the use of the application provided access controls. Kind of sort of in the middle is platform as a service. The provider offers a platform where customers may run applications they have developed themselves. The provider will build and manage the infrastructure and offers customers an execution environment like code libraries, services, and tools. The other one is function as a service. Allows customers to upload their own code functions to a provider. The provider will execute those functions on a scheduled basis in response to events or demands. Function as a service is also referred to as serverless computing. There are a couple of cloud deployment models, 4 that you should be familiar with in the test. There is the public, which is accessible to any customer in a multi-tenant model. A single customer may be running workloads on servers spread throughout one or more data centers, with those servers running workloads for other customers simultaneously. There is the private. Any infrastructure that is provisioned for use by a single customer. It may be built and managed by the organization using the infrastructure, or built and managed by a third party. So the public cloud would be like your GCP instances for this class, where you just spin up VMs and they run, and you don't know what actual physical hardware you're running on. And that physical hardware is more than likely running VMs from other people too. A private one can simply be a cloud infrastructure that you built yourself for access only for you. Or it could be that you pay a cloud provider like AWS to set aside a couple servers to be only for your use. There's the community cloud. Services run a multi-tenant environment, but the tenants are limited to members of a specifically designed community based on shared mission, similar security and compliance requirements, or other commonalities. A community cloud, for example, is the Bay Area's the NetLab, where the 28 community colleges plus any partners are able to utilize that infrastructure, but it's not open to the general public. The last one is hybrid. It's a catch-all term. It's a blend of public, private, and/or community cloud services together. Hybrids require use of technology that utilizes different cloud offerings into a single coherent platform. This is useful if a firm has a private cloud and leverages a public cloud when the workload or demand exceeds private cloud capacity. So hybrid can be a spillover in case, for example, the public cloud gets too overrun. No matter where you host your infrastructure, always think about the CIA triad: confidentiality, integrity, availability, and implement strong access controls and other mechanisms. Cloud security operations differ from on-premises because cloud customers must divide responsibilities between one or more providers. In the platform as a service, the vendor takes responsibility for the operating system, whereas customers will retain responsibility for data being placed into the environment and configuring security. In SaaS, the provider takes on almost all security responsibility, and the customer retains some shared control over the data. So depending on what model you're using will depend on who is responsible for what. So if you're going with infrastructure as a service, then you, the user, have way more control over everything and are responsible for more. If you go all the other way to software as a service, then it's the provider who has more responsibility. There are a couple of cloud standards and guidelines that you should be familiar with. And I know this looks scary, but the two that you need to be familiar with are the Cloud Reference Architecture. It's published by NIST in the SP 500-292 that has an example of how elements fit together. There's also the Cloud Security Alliance, an industry organization that develops and promotes best practices in cloud security with their Cloud Controls Matrix. Any questions on this, on the cloud talk so far? Switching gears to the technology that made cloud possible, virtualization. Virtualization allows multiple guest systems to share the same underlying hardware. The virtual host runs a special operating system known as a hypervisor that mediates access to the underlying hardware. Hypervisors enforce isolation between virtual machines, which means each VM has its own separate physical dedicated environment. Isolation also ensures that VMs don't interfere with each other. The two main types of hypervisors are the type 1 and 2, as seen here. Type 1, which also is called a bare metal, runs directly on the underlying hardware. So the hypervisor is the operating system. Like Hyper-V, oh no, not Hyper-V, VMware's ESXi or Proxmox. Type 2 hypervisors run as an application on top of an existing operating system, like VMware Fusion, VMware Player, or VirtualBox. Those are all applications that run on top of an operating system. As discussed, servers are the basic building blocks of computing capacity in the cloud, providing CPU, RAM, storage, and networking connections to access and utilize the system. Here is an example, a different example of the three main services. Containers are another thing that you need to be familiar with. Containers provide application-level virtualization without the need of an operating system. Containers package applications and allow them to be treated as portable units of virtualization. The interface becomes consistent, regardless of the underlying OS or hardware, while sharing similar security considerations with virtual machines. Containers are an interesting mix because it's not a full virtual machine as it would be with something out of VMware or something out of Hyper-V. It doesn't have its own operating system, but it does utilize whatever it's running on. And because they're easy packageable, they can be used in multiple systems and be transferred relatively easy and set up just the same way. The most infamous of them all is Docker. Cloud storage. You have two main items. They are the block and the object. Block storage allocates large volumes formatted as virtual disks by an operating system to be used like a physical drive. Objects place files into buckets and treat each file as an independent entity that may be accessed over the web or through a provider's API. Object storage hides the storage details from the end user. Object storage is highly scalable because it doesn't go by the rules of a typical hard drive. It's not really. It's more of a bucket where things are dumped and then searched for later. So when working with this type of storage, keep in mind that you should always set permissions properly, especially with object storage, because a few clicks can inadvertently publish a sensitive file. If permissions are not set properly, you get those things in the news about, oh, a bucket of information was exposed and a hacker downloaded it all and now it's up for sale. Consider high availability and durability options. Either use replication capabilities provided by the cloud provider or implement your own. And also use encryption to protect your sensitive data. Either apply your own or use from the other provider. All of them have that availability. It's up to you to set it, though. When it comes to networking, you should enable things like security groups. Set network traffic rules that are substantially the same as a firewall rule set to define permissible network traffic and prevent everything else. Use virtual private clouds or VPCs. These are the cloud's equivalent of a virtual LAN. Cloud transit gateways extend VLAN models further by allowing direct interconnection of cloud VPCs with on-premise VLANs for hybrid operations. Virtual private clouds, VPCs, are actually great for inter-cloud communication because a lot of it can be happening within the physical box itself that is running on somewhere in a data center, which means it's going to connect a whole lot faster than going from one machine to another machine over a network. Now, as fast as a backbone is, transferring data from RAM to RAM on the same box will always be faster and tends to be the fastest way to get data across. So if you are able to interconnect cloud VMs using a virtual private cloud, I highly suggest it. There's also the DevOps and cloud automation. DevOps brings together the development and operations in a unified process where they work together in software development. Software testing becomes highly automated and collaborative. Infrastructure as a code, or infrastructure as code, seen here, is the process of automating the provisioning, management, and deprovisioning of infrastructure services through scripted code rather than human intervention. So by using something like this, a file just like this, I run this file, and in AWS, it'll create a virtual machine with a specified hard drive, or two specified hard drives, actually. Say the type of system that we want, where we want it, and everything. No longer do you have to go clicking around to set things up or use a wizard. You just send the file through and it will provision as written. Makes life a whole lot faster, especially when we need to scale. Now, if you need to make 10 machines or 20 machines on the fly, it's much easier for a cloud provider to just reference a file and build upon that rather than waiting for you to give all the specifications and everything else. Of course, we can't talk about cloud without talking about some issues. The first issue is availability. Cloud providers operate in different geographic regions with mechanisms for backing up data across their regions and operate in a high availability mode across zones. Now, while the cloud provider does that, that doesn't necessarily mean that they will do that for you. You have to set that up. You have to configure your infrastructure to jump from one data center to another. Or another workaround is building it across different cloud providers so that when one goes down, another can take over. The second cloud issue that you need to be aware of is data sovereignty. This is a principle That data is subject to the legal restrictions of any jurisdiction where it is collected, stored, or processed. Some providers will offer explicit control over the use of resources in specific regions. Two places that this comes in mind is China and Europe. Under GDPR, data that is created in Europe has to stay in Europe unless you go through a legal process to allow data to leave. Similar in China, data that's there has to stay there. So if you are building your infrastructure to always be up no matter where on the planet, then you need to take that into effect into your thinking of where are we going to have our other data centers should one go down. If you build it in Europe, you have to go by their law. Just because things are in the cloud does not mean you are free from virtualization security. There's a lot of virtual machine escape vulnerabilities that allow attackers to hit the virtual host and intrude on resources. This is why your virtual machine should always be up to date, along with any applications they are running or hosting. There's also virtual machine sprawl that occurs when infrastructure as a service users create virtual service instances and they forget or abandon them. Remember, anything that you have in the cloud that is running will accrue a cost. So if your users aren't being vigilant about turning off or removing unnecessary services, those will rack up costs. When it comes to the applications you run, you must secure your API. You must implement secure coding practices and utilize secure web gateways. There's also governance and auditing, ensuring IT organizations are consistent with organizational strategy and policy. Auditability provides customers with the assurance the provider is operating in a secure manner and meeting contractual data protection obligations. Lastly, we have some cloud security controls. The first one is the cloud access security brokers, software tools that serve as intermediaries between the users and providers. They can work in line physically or logically through hardware appliances or endpoint gateways or agents, requiring configuration of the network or those endpoint devices. Having the cloud access security brokers in line has an advantage of being able to see the request and allow or deny them before they reach the cloud. API-based do not interact directly with the user, but they work directly with the provider's API. Though it doesn't require a user device configuration, it doesn't allow a broker to block requests that violate any policy. Another security control is resources. Limit the actions that a user can take, like accidental command, using compromised accounts, or even malicious insiders. And the last one is managing your secrets. Having hardware security modules can manage encryption and perform cryptographic operations. They can create and manage encryption keys without exposing keys to a human, minimizing the risk of a key getting compromised. Now, I'm not sure what happened with Zoom. Apparently, it loaded the wrong meeting, which is odd. So I'll troubleshoot that in a moment. But for the recording's sake, I want to cover the work for this week. Instead of doing Try Hack Me Rooms this week, you're going to do some research. And this does not mean you need to do a 10,000 page essay. I gave you 4 basic questions to answer. Look at GCP, look at AWS, look at Azure, and look at DigitalOcean. See if you can answer these 4 questions for each. It may require doing some Googling, looking at their policy, seeing what you can pull out. That's the purpose, is just answering these 4 questions. And again, I'm not expecting a really long research paper. I'm expecting some well thought out and researched answers. So with that, I'm going to stop this stream and restart Zoom to see if it loads in the right place.